Hello viewers, welcome to CAE for you. Fatigue crack growth studies are gaining traction because typical manufactured product would contain cracks which cannot be avoided. They can be very small, even in micro scales. But the good news is all the cracks are not harmful, while there could be some. So studying their growth is of paramount importance. As the crack grows and reaches a critical length specific to the material that has been used, the crack would grow very fast, leading to literally breaking into pieces. So studying them becomes critical to find the remaining useful life. The advancement of inspection technologies makes them a key candidate for preventive maintenance planning through Internet of Things. Often these calculations are difficult to do analytically due to complex stress field and multiple critical cracks. Numerical simulation technologies are also often limited, complex, and many times would require multiple simulation stages. This video aims at serving a technological demonstrator for open source tools for simulating such a complex phenomena. For this work, we have used Salome Platform and Calculix. Modeling crack growth accompanies with its own challenges. First is multi-stage simulation. That is, a base model has to be calculated with 3D elements. For LCF calculations, a static analysis will have to be performed. Then the crack front has to be modeled with first order triangular shell. Since the accuracy of the simulation depends on the stress field in base analysis, second order elements are preferred, which means the preprocessor being used for this kind of simulation should allow creation of mixed elements and mixed order mesh. Next is the material properties needed for crack growth modeling. Calculix use Paris crack growth type calculation model, which will ask 8 constants. The accuracy of the constants will affect the accuracy of the results. Further, can demand trial and error or regression based methods to fit the crack growth curve with reasonable accuracy. For more details, viewers can refer to the crack propagation section in the user manual. In crack growth numerical simulations, cracks are initiated with pre-crack surfaces, and though Calculix allows surface-based crack front definition, it is necessary to identify the correct crack location and its orientation for life estimations. Without prior experience, this can be a challenge. The accuracy is limited by the crack model itself. Hence, the limitation of Paris type crack growth model will apply. Again, rigorous validations will be required to use this approach for real-world problems with correction factors. Our current work was inspired by a publication on fatigue crack growth test, but it is emphasized that our work is not a true replication but a workflow demonstrator along with some conservative assumptions. It is recommended to the viewers that referring the publication can be helpful for obtaining better insights. Moving on to the workflow, we will be modeling a hollow shaft of inner diameter 40 mm and outer diameter of 50 mm. The transverse hole dimension is of 5 mm radius through hole. A pre-crack has been oriented at an angle of 45 degrees of length 5 mm, which will be the major crack. However, for demonstration purpose, we have created 2 crack fronts of various initial crack lengths. Again, this is to demonstrate the software capability. The shaft was subjected to a varying torsional load of 6 kN and axial load of 10.4 kN. As we move on to the tool chain, we have used Salome Shaper module for creating the geometry and meshing. Salome native mesh was converted to Calculix readable mesh file using UNV2 CCX application. We could see Salome platform could create mixed element type with element orders. Further, structured mesh was possible for computational efficiency. Then, a static analysis fixing one end and applying the torsional and axial load at other end was carried out. We observed that the crack orientation is close to the maximum stress of interest. Subsequently, crack propagation analysis was performed to calculate the crack length and cycles. With this, we complete the workflow. It is well known that the major problem with open source tools are lack of guiding documentation and tutorials. For easy adaptability, this documentation can be of great help. Realizing the need, we prepared an entry-level tutorial covering the workflow. Let's take a glimpse of the tutorial. Press enter to see the preview of the geometry. We are satisfied with the hollow cylinder. So click apply to accept the geometry. We have created the submesh. Now we can check for the preview. The preview is successful, which means there is no errors and we were able to create the complete mesh. We notice that the maximum stress is roughly inclined 45 degrees in the hole and the maximum principal stress is exactly aligned with the crack. So we see the result. There is a crack propagation. We also see that the crack is getting deflected depending upon the stress field. The tutorial is available in Gumroad for a nominal price to support more of such content. The link is available in description. If you need any assistance for your work or further details, write to contactcaeforyou@gmail.com. That's all we have for you now. Stay tuned for more such videos.